Okay, Assalamualaikum and salam sejahtera. My name is Asyraf Arusydi bin Affendy. I'm from Bachelor of Mechanical Engineering Technology with honors with metric number of B0919106162. My main supervisor is TS Dr. Muhammad Haider bin Maslan, and my title is the effect of fiber orientation on tensile and impact properties of Bemban fiber reinforced composite. Okay, moving on to the next slide will be the introduction. First of all, the background study. W.D. Rick Brower in 2003 stated that the composite materials have been applied for centuries. It all began with natural fibers. To make walls, clay was strengthened with straw in ancient Egypt 3000 years ago. Natural fibers were used in large-scale manufacturing quantities of sheets as early as 1908, according to Blesky and Kazan, where phenol or melamine formaldehyde resin sheets were reinforced with paper or cotton. Natural fibers eventually disoriented a lot of the appeal. In the 1960s, composite materials began to gain popularity when the large quantities of glass fibers were combined with tough, rigid resins. Natural fiber has regained popularity as a glass substitute in the last decade, and the natural fiber composites are popular due to their superior electrical resistance, thermal and uh, thermal insulation properties, and resistant to fractionation. Other fibers have lower stiffness per unit, renewability and biodegradability than flax, knauf, hemp, jute, and sisal. Natural fibers are less expensive than synthetic fibers and may be used in application where cost trumps strength. Okay, next is the problem statement. For this experiment, Bemban has a lot of potential. It is easy to find and can be found anywhere throughout Southeast Asia and mainly used for handicraft products as well as the tiles. Bemban plant has a lot of potential on becoming a good natural composite as knauf and jute due to its high strength, high durability, high flexibility, and will not easily damaged by water. Regardless, there is no precise knowledge on how to correctly handle the Bemban plant. To begin with, the Bemban plant has a few characteristics that make it a great natural composite. It contains minimal sap and it is simple to process. However, there are few studies to analyze on the strength, water absorption, flexibility, fracture, and failure process of the Bemban plant. So this study will be beneficial to the commercial and industrial sector when the strength, toughness, and the degradation factor has been known. Moving on to the next slide is the research objective. Basically, there are three types of research objective, which is the first one will be to study the mechanical properties of Bemban fiber reinforced composite. Second is to study the effect of different types of orientation of Bemban fiber reinforced composite with tensile and impact tests. And finally, uh, to study the potential of Bemban fiber reinforced composite. Okay, as for the scope of research, there are four, which is firstly is the materials chosen for this experiment study are Bemban and thermosets. Next, this experimental study is focusing on three types of orientation of Bemban fiber reinforced composite, which is unidirectional, woven, and also random. The investigation will concentrate on the tensile and impact properties of Bemban fiber reinforced composite by using the tensile machine and therapy machine tests based on ASTM D3039 and ASTM D6110 standards respectively. And lastly, the samples will be examined under an optical microscopes for better understanding the damage process. Okay, for the literature review, I will explain about the first thing, which is the Bemban. So Ahmad Sharif in 2017 stated that Bemban is another type of plant from Maran Takai family that looks like a bamboo tree that grows in Malaysia. The morphology of this plant is that the leaves are oval in shape with parallel veins at the end of the stem and are green. It often grows in areas of shrubs where there is moisture suitable for clumping. Although this plant is not considered as a food crop to be commercialized, but this existence of this plant is always utilized by the villagers. At first glance, this Bemban tree is a kind of clump plant with a stem that looks like bamboo tree, but it has no segments. The relatively large oval-shaped leaves have a beautiful glossy surface. Uh, the stem features a tall stem with the leaves located at the tip of the stem, where the flowers are white and produce a weak pregnant odor. The fruit is round and small in size. Fruits are globoid to ellipsoid in shape and slightly hairy and whitish in color. It is fairly common, particularly in open and crowded areas. The plant can also be found in wet areas such as swamps and areas that flood on a regular basis. In Southeast Asia, it grows up to 1000 meters of altitude, not only in secondary forests, thick forests, and bamboo forests, but also in coconut plantations and near paddy fields. Okay, next will be the composite. Uh, Moti on February 2020 stated that a composite material is a material that is made up of two or more materials that have better properties than the individual components when it is used separately. Which in contrast to metallic alloys, each material retains its own chemical, physical, and mechanical properties. The two components are reinforcement and matrix. Composite materials have a high strength and stiffness mixed with a low density, allowing for a weight reduction in the finished item as compared to bulk materials. Strength and stiffness are provided by the reinforcing phase. Typically, the reinforcement is tougher, stronger, and rigid than the matrix. Fiber or particulate is commonly used as reinforcement. Particulate composites have essentially identical diameters in all directions. Continuous fibers composites are weaker and less rigid than particle composites, although they are typically less expensive. Particulate reinforced composites often have less reinforcement due to processing challenge and brittleness, which is up to 40 to 50 volume per percent. Next is the effect of fiber orientation on composite impact and tensile properties. So Jim Kim on May 2010 stated that the position of fiber themselves or fiber orientation determines on how much reinforcement improves strength, elasticity, and manufacturability. Injection molding fiber orientation refers to how individual fibers are arranged in fiber reinforced polymer composites to facilitate optimal structure arrangement. As the injected materials flow through the mold, the resulting fiber alignment changes the geometry of the mold cavity, which has direct impact on mechanical properties. The polymer matrix, fiber reinforcement, and the fine interface region make up fiber reinforcement polymer composites. It also determines the properties of the composites, such as the chemical resistance and grip. If the matrix is flash and the fiber reinforcement are bond, the result is strong composite only. Moving on to the next slide will be the methodology. So figure on the right shows the flowchart. So basically, the project title will be proposed to the supervisor. So if the title is approved, it will be proceed to the identify the background study, problem statement, project objective, and scope of the study. Next, it will be perform the literature review. After that is to identify the project methodology for project planning. If we success, the if there is no correction, will the report will be submitted and the presentation of the uh, FYP1 will be held. So next will be the experimental setup flowchart. So first of all, is to process the raw Bemban, and then will be mixed with and then the Bemban fiber will be mixed with the mosaics. After that, there are three types of orientation. Which is the unidirectional, movement, and also random. After that, the test will be done, which is the test will be held, which is the tensile test and also impact test. After that, the result will be examined by using the optical microscope. So basically, this is the process of raw Bemban, where the stem is cut and the fiber of the Bemban is obtained. So last but not least is the expected results. First of all, able to recover the details and information about Bemban, fiber, matrix, composite, and natural composites. And lastly, I will be able to examine the failure and damage on the Bemban composite with optical microscope. So that's all for me. Thank you and Assalamualaikum.